Today we're going to be talking about linear transformations of f of x equals x. F of x equals x is our linear parent function. This is our function version, or our function notation. Our equation, remember function notation has the f of x, our equation has the y. Y and f of x are the same thing. Now, every equation, right, wherein y equals mx plus b has an m and a b. So the number in front of x, my slope, is 1. B, my number I'm adding or subtracting onto the end, notice how there isn't 1, so that means it is 0. Okay, there are 3 different types of transformations from a line. And what I'm talking about with transformations is the linear parent function is the most simple form of linear equation. All lines come from the parent function. All lines are transformations of the parent function. And there are 3 different types of transformations. The first type of transformation is a dilation, and there can be 2 different types. There is a stretch where the line is getting steeper, or a compressed where the line is getting flatter. And that is controlled by M. There's a reflection. Remember, our lines can either be positive, where they're going uphill, or negative, where they're going downhill. And that is controlled by whether M is positive or negative. Because if M is positive, it's going uphill. If M is negative, it's going downhill. And then the third type is a translation, and that is controlled by the y-intercept. The y-intercept will translate or slide or shift your line up or shift it down. Okay. Now let's talk a little bit more about reflection. The reflection is controlled by the sign of M, whether or not it changes between positive and negative. If the sign does not change, it is not a reflection. The sign does not change, it is not a reflection. Okay, if you notice, on my first example, I start off with a negative slope, and I change to a positive slope. That is a reflection. On the second example, I start with a positive slope and I change to a negative slope. That is a reflection because the line changes, or the sign changes. Okay, now let's talk about translation, whether it's a shift up or a shift down. If it's shifting up, we're increasing. If it's shifting down, we're decreasing. This is caused by changing the y-intercept. Once again, if b increases, there's an increase in b, then I shift, my line shifts up. If b has a decrease, then there is a shift down. Okay, so let's look at our examples. On my first example, I start at 17 and I shift to 29. That is an increase of 12. So I shifted up 12 units. On my second example, I started at 4 and I moved to -5. I decreased by 9. That means I shifted down 9 units. And then there's dilation. And it's talking about how steep or flat the line is. Remember, when I'm talking about steep, I have a stretch. If it's flat, I have a compress. Now, when we're talking about this, we do not use the sign, okay? I want the absolute value. The absolute value of 3 is 3. The absolute value of -3 is 3. The only difference here is if I have a +3, it's steep going uphill. If I have a -3, it's steep going downhill. That's the only difference. It's still going to be steep, okay? So if m increases, I'm going to have a steeper line. If it's getting steeper, it is closer to the y-axis. If m decreases, it's getting flatter, and that will be closer to the x-axis. Okay, so let's check this out. So on this one, I change from 3 to 2. Well, 3 is greater than 2. I have a decrease. So it is getting flatter. The way I would say that is g of x is less steep than f of x. Not then, than. On my next example, remember, I'm ignoring my signs. I'm only looking at the number. I go from 3.5 to 8. 3.5 is less than 8. I have an increase, so that is steeper. So g of x is steeper than f of x. Okay, my last one, I look at 4, which is going to 7. 4 is less than 7. I have an increase, which means it's getting steeper. So g of x is steeper than f of x. Okay, I will see you in class.